So we had these theorems. I don't know if we are seeing the board. Are we seeing the board?
Yes.
All right. So we had our theorems. I'm just going to explain as we move. Some of them we explained them. We talked about this part of our theorems. From the first part, we are given here a chord is a straight line joining 2 points on the circumference of a circle. So AB is a chord. I think we talked about this from the properties of a circle. Then the only part that we didn't talk about was the issue of a tangent. So if we are to check here, we are saying where there is a tangent, what actually is a tangent? That is the first thing that we are supposed to understand. That a tangent is simply a straight line that touches the circumference of a circle. If a circle is drawn like this, then a tangent is simply a straight line that is going to touch the circumference of a circle. That is what we call a tangent. It is not going to pass through the circle. We are given a circle like this, then we've got a line like this. This one is not a tangent. This one is not a tangent. A tangent touches only the circumference of a circle. We shall talk about this also in graphs. When we are dealing with graphs, when you are given a curve, a tangent is simply a line again that is going to touch the curve at a certain point. So that is what we have on a tangent. So our theorem is, if we are having this tangent that we are given a tangent in this case, when it is drawn from a circle, then we've got from our center to the tangent, which is our radius. So here we are talking about the radius. So if a radius and a tangent meet like this, they will meet at 90 degrees. So meaning to say this angle on this side will be 90 degrees, this angle will be 90 degrees. So our theorem is if a tangent, a radius and a tangent, they meet at 90 degrees. So the shorter part that we can simply say here is that the radius that is the radius and a tangent, they meet at 90 degrees, and a tangent meet at 90 degrees. So that is our theorem. So, but remember that where there is a radius, there is also a diameter. It cannot be a radius only, it can be a diameter like this. So the concept does not change. If we are given it as a radius or we are given it as a diameter, remember I was saying a diameter, we are seeing from the one point of the circle, but it must pass through the what? The center. So the concept in this case is going to remain. We are going to have what? 90 degrees. So these are the theorems that we are supposed to work with and understand. All right. So we are going to see examples on this one. Then we have got this part that states that from the two tangents that we are talking about, we are talking about the tangent. Now we've got two tangents, A, C, this one being a tangent. It is drawn from what? From the point of a circle. BC being a tangent, BC drawn also from the point of a circle, this BC. So it's also a tangent. So it follows that if these tangents are being drawn like this from the same point, which is C, to the circumference, they will be equal in length. So these lines, they indicate that these two are equal. So we are simply saying two tangents on the circle that meet at a point outside the circle are equal in length. That is from A to C, B to C. So we are simply saying AC is equal to BC. All right, we are already given here AC is equal to BC. But let's take back again this part. We said if we are given a radius and a tangent, they meet at what? At 90. So if we check, that's the same condition that we are having here. We have got O as the center. This becomes our radius. So this radius and the tangent, when they meet, they are going to meet at what? They are going to meet at 90 degrees. So that is what we are seeing on this case. So it's a special part that we are having a repetition from this part. 90 degrees there is the same thing that we are seeing here, 90 degrees. So meaning to say this angle is 90 degrees. This angle also is 90 degrees. Also, we've got a radius again to the tangent. And also to note, a
So
radius.
someone was saying,
Hello?
Somebody is asking to join.
All right, let me check. Okay. All right. So if we check on this part here, if we check on this part that we are having, from O to A, it's a radius. So the radius concept, you are simply saying radii, the radius concept, they will be equal. So the radii concept now is when they are many. So if we get O to this point, it can be O to this point, it can be from O to this point, it can be O to this any point, as long is taken from the center, it means they are the same, they are equal. So you're simply saying the radius here are equal. That is from O to A and from O to B. That is what we are seeing these two lines here indicated to say, to mean that these two are the same. But my question is, if we are saying this angle is 90 degrees and also this angle is 90 degrees, this is the additional part that we are simply taking from here. What is going to happen between these two angles here, the angle at O, this one, and the angle at C? What is going to be the relationship between angle O and angle C? What can we say about these two? These two must add up to 180. Why? We are having O to A to C to B, or A, C to B, or A, C, B, or I don't know the way that you can take, which is representing a normal quadrilateral. So this is not a cyclic quadrilateral, no. It's just a normal four-sided shape. So it's a special type of a shape that we can see, which is a kite. These are the from properties of a kite. These two sides are equal. These two sides are equal. So here we are representing a kite. That's the special name of this quadrilateral. But my question is not about the properties of this shape, the name and so forth. I want to understand what is going to happen between these two angles here. This angle at O and this angle at C. All quadrilaterals, as long as shape has got four sides, it means its interior angles they add up to 360 degrees. But if you check here, we have removed the 90, we have removed the 90 here. So if we add these two 90s, we get what? 180 degrees. So it means out of 360, we are going to remain with 180 because we understand 180 plus 180 gives us what? 360 degrees. So it means if we are saying these two angles, they are giving us 180, it means the remaining angles, which is the angle O plus the angle at C, must give us 180 degrees. So this is another advantage that we can put into consideration. Say these two angles must give us 360 or must give us 180. But on a consideration that we have got this angle, then you want to find this one, still you can use the 360 degrees concept. Add all your angles, subtract them from 360, then still you can find the remaining angle. It's fine. But if you can note this one in short, it can actually help us a lot. So that is on a tangent. So we shall check questions which are related to this part here of a tangent. Then we've got this one. I explained it, if you still remember, that a diameter subtends an angle of what? Of 90 degrees at the circumference of a circle. So it can be any way. We can have this diameter also subtending an angle like this at the circumference, meaning to say this angle is going to be 90 degrees. So as long it's taken from what? A diameter. This diameter is the one that is creating the angle. So it is creating an angle of 90 at the circumference. We talked about this one, and also we talked about angle at the center being twice angle at the circumference, and also angles subtended by the same chord, they are equal, meaning to say AB here is our chord or arc. This chord here creates equal angles at the circumference. We also talked about this. So I want us to check some relations that we have from these questions. You were saying there was a challenge on question number 3. Is that so, Ntombi?
Yes.
All right, let us see that question. Then we shall check. These theorems, some of them we talked about them and so forth. And I think this booklet had got enough examples that were given. So let us revise on it. So many questions that we have there. And also the answers, if you check at the back, there were answers at the end. So That was an advantage of this one. Question number 3 from this exercise, and that was the first exercise, this one. Exercise 14A. Is that so?
Yes, yes.
All right, this question number 3, it's in Fig 14.9, PQ are points on the circle center O. If OPQ is 36 degrees, what is the size of PRQ? All right, let's check our diagram. Where is our diagram? There was no diagram in Fig 14.9. Okay, this is our Fig 14.9. All right, this one on top here. Are we seeing the Fig 14.9? Let me try to put it this side. We were given the Fig 14.9. This is the one here, Fig 14.9. So on Fig 14.9, this is our diagram here that we are relating to. All right, so let us see what we are given. We are told that OPQ, that is from O to P to Q, this angle is 36 degrees, the one that we are given. What is the size of PRQ? PRQ. All right, this angle here. All right. Okay, yeah, that's all. What can we do? Let's try to work with our properties. We understand this angle that we are being asked to calculate here, it has a relationship between the angle or this one. What is the relationship between angle R here and angle O from our theorems? What do we know about these two angles? Angle O here is at the center. Angle R is at the circumference. So you understand that angle O is 2 times angle R, twice this angle. Angle at the center is twice angle at the circumference. So it means for us to calculate angle R here, let us target from angle O, because on this we have got a triangle that at least we can play around with to calculate the angle at O. At least we can try it by all means. So how can we calculate the angle O? What can we do? The angle O, which is POQ, you can write it as angle POQ or just angle, I don't know the way that you want to write it as. Remember what we said about the radius concept. From O to P, what do we have? From O to P, what is the special name of this line? It's a radius from the center. So we've got a radius which is equal to OQ, because we said the radius, that is the radii are the same. That is from O to P, it's a radius. From O to Q, it's a radius. So these two are equal. So if these two sides are equal, what is it about triangle POQ? It's a special triangle that is being created there. What is the special name of this triangle? POQ. What would be the special name? That would be an isosceles triangle, which gives us to say the base angles are equal. The angles which are opposite these sides are equal. This side here, it's opposite to this angle. So this angle here, this side is opposite to this angle at Q. So it means the angle at Q and the angle at P, they are the same. So that means at Q here, we also have 36 degrees. That is what we have at Q. So we can calculate angle O, which is angle POQ. How can we calculate angle O now? Which concept are you going to use? Angles in a triangle add up to 180. So if these angles add up to 180, it means the angle at O, we are simply going to subtract all these angles from 180. 180 minus these two angles, 36 degrees plus 36 degrees. So that means our angle O is going to be what? 180 minus these two, that will be 72. 72 here. 180 minus 72 is what? 180 degrees minus 72. What do we obtain? That will be something like what? 108. That's true. That's so. 108. So here we are having an angle of 108 degrees, which is the angle at O here. So we are saying this angle is 108 degrees here. So if this angle is 108 degrees, but before we're saying the angle at the center, which is O, is twice the angle at the circumference, which is R here. So how can we calculate angle R now from O? Because now we are moving from the center to the circumference. From the circumference to the center, we're multiplying. What about now vice versa? We're going to divide by 2 exactly. So meaning to say our angle PRQ, which is our angle R. So this one indicates that we are talking about the angle at what? The angle at R. So it is going to be 108 degrees divided by 2, which is going to be 54 degrees. So that was the concept here. So this angle was going to give us 54. All right. I don't know. Any other part? Let's see any other part, so that we can revise it before we check other questions. Any other part? Oh, that was the only challenging question.
Maybe let's also do number 12.
Number 12 from these questions.
Next one.
Or
Just the next one.
From those ones that the previous ones.
Yes.
All
I think
right.
it's 14.8.
On these questions, or on from the NGM book 3?
The previous one, Fig 14.8.
Fig 14.8. That all right. Let's see. Fig 14, or on this one?
Yes, this one.
All
Yes.
right. Our question, where is okay? Our question is on top here. All right. So here we are given in Fig 14.8, PQ, PR and S are points on a circle. So we've got these points, circle, center O. If POR is 150, PO to R, this angle 150, calculate PSR. Okay. How can we calculate angle PSR in this case? All right, we want to calculate angle PSR. What can we do? This angle here, PSR. This PSR, it's an angle that is at the center, affected by this angle at this angle at the circumference, affected by this angle at the center, this one. This is what we are supposed to understand here. This angle S is affected to angle POR, this one. This POR, this one. This is the one that is affecting our angle S. So angle at the center is twice this angle. This one, do not confuse this angle 150. 150 affects this angle if we had a line like this created from like this one. This angle here is going to affect this angle. So are we seeing the relationship? One is inside, the other one on the other hand. This one, the other one on the other hand. They are not supposed to be like this, to say this one or like this. This one is a wrong relationship. It must be one on the other side, one on the other side, one on the other side, one on the other side. That is how we can take this part. So if we are saying this angle here is twice angle S, so let us calculate this angle POQ, which is called the reflex angle. Any angle that you see in this format where there is an angle inside, then we are talking about the outer angle in this shape is referred to as a reflex angle. So meaning to say, we are going to calculate the reflex of what? POR. POR, a normal angle, which is not a reflex angle, they will just state POR. That's why here they just stated if POR is 150. But there's another POR here on the other side. How do we name this side? It's POR, this angle. So, but it's a reflex now. So we are saying reflex POR can be calculated. How are we going to calculate our reflex POR? Angles at a point add up to 360 degrees. So meaning to say, we are simply going to subtract this one from 360 degrees. So 360 minus 150 is going to give us what? Something like 210. So this would be 210 degrees. So meaning to say, this angle here is 210 degrees. If this angle here is 210 degrees, what about angle S? Now we can determine angle S, because this angle at the center is twice this one. So meaning to say our angle PSR can be calculated just like the previous part. We wanted to calculate the angle at the circumference from the one at the center. We simply divide by what? By 2. So this is going to be 210 divided by 2. So the moment we divide this, we are going to have our PSR. So 210 divided by 2 is going to be what? Also take note on this one, how we are going to divide here. 2 into 2, that will be 1. Then here it's not 2 into 10, that will be wrong. We divide digit by digit, so it's 2 into 1, which is what? A 0. Then we give a 1 here. 2 into 10, which is going to give us a 5. So this one is going to be 105. Because these questions normally you might have them in paper 1. So on the division part, they take note. All right, that was our question. So I don't know if we are together. If we are together on this one.
Yeah.
All right. So that is how we're supposed to attempt this question. Let's check another one. If there's another one. If there is another one. If there is another one. Let's check before we move on. Oh, those were the challenging questions. All right, no problem. So I want us to check this part here with our theorems we added. That if we are given tangents and so forth, but if you check on your questions here, you had not a question that involves a tangent or that needed us to apply any tangent concept. All right, so I want us to apply the same information that we're talking about on question number 8. Then we move on to the cyclic quadrilaterals so that we can add 1 or 2. On question number 8, we are supposed to calculate the values of the unknown that we are given. So, okay, if you have an answer, you can give us an answer for the letter that you see and also the theorem that corresponds to that answer.
Okay, angle Z is equals to 90 degrees, I think.
Angle Z is equal to 90 degrees. Why? I want us to correct it from there. Why are you saying it's 90? The theorem is from which one?
Isn't that a tangent?
All right, this line is not a tangent. Why? We said a
It's inside
tangent,
the circle.
it's inside the circle, this one. A tangent must only touch the circumference of a circle. That's a tangent. It must only touch the circumference, not to be inside like this. It's no longer a tangent. That's the first thing. Number 2, we do not have any radius drawn from this point. From this point here, from this point up to this point, this one is not a radius. So this theorem is not valid. So we can't have Z for now. All right, we can't have Z for now. What can we do? What can we do? Which part can we find?
I think we can also find x by multiplying by 2.
X. X.
Yeah,
Which one
yeah.
are we?
We can.
Which one are we finding if we multiply 126 by 2?
X.
No, it's actually W. I think
It's W. This one is
we
this
can find.
one.
Yeah, we
Are we
can find
seeing?
the. Yeah.
This is the one that we are finding. Remember what I was saying? Angle at the center. It is not supposed to be. They are not supposed to be like this. We are not supposed to take this relationship. This is not how it works. It's one of the angles is outside like this, the other one is in. They are opposite. Are we seeing the relation? This one and this one. Here we are referring to x must be related to y. This is how we take angle at the center, angle at the circumference. Angle at the center, angle at the circumference. They are not supposed to be taken inside to say this one and this one here. No, we are not supposed to take these ones inside. Are we seeing the relationship there?
Yes.
So meaning to say, in this case, we can be able to calculate W. This is the one that we are relating to 126. So W is going to be 126 times what? Times 2 angle at the center, which is twice. So what are we going to obtain if you multiply 126 by 2? That will be something like 152, not 252.
No, 252. Oh, sorry.
252. All right. So this angle here is going to be 252 degrees. Then from W, which one can we calculate? From W, which one can we calculate now?
I think we can also
Y. Okay. Y from 252. Remember we said these two must not be taken like this.
I think we can calculate x.
So
we can say 306.
So we can calculate x here because they are on a point. So x is going to be 360 minus what? 252 degrees. So we can calculate x. So 360 minus 252 will be something like 108 degrees. So we now have our x here. All right. From x now,
And then
we can calculate
y.
Now we can calculate y from our x because this is at the center related to this one. That is our relationship. So meaning to say y is simply half of what x because it's at the circumference. So that is going to be 108 degrees divided by 2. So y at the end is going to be what? 50 what? 54.
54.
So that is our angle y here, 54 degrees. From y, which one can we calculate? Now we can calculate z. Y and z, they are found what? On a straight line. Are we seeing the concept? And we say angles on a straight line add up to 180. So z is going to be simply 180 minus what? 54 degrees. So that is going to be something like 126. So here we are now talking about angles on a straight line. I want us to check what is happening between z here, which is 126, and this angle here, which is 126. Because we are saying this, our z here is 126 degrees, and it's also equal to this angle. And there's a theorem that we talked about between these two, which was from a cyclic quadrilateral. We said the exterior angle of a cyclic quadrilateral is equal to what? To the opposite interior. If you are given a cyclic quadrilateral like this, if you extend one side like this one, this becomes our exterior angle. So this exterior angle is equal to the opposite interior. This is the interior, but the opposite one, this is the one that we are relating. So these two, they will be equal. So exterior angle is equal to the opposite interior, which is this angle at this point. So if we check, this is exactly what is being proved here. The exterior angle is equal to the opposite interior angle. Also on a cyclic quadrilateral, we said opposite angles of a cyclic quadrilateral, they add up to 180. These opposite angles, they must add up to 180. So if we are using this concept, we can also prove that we could have calculated y, this one, from 126, because we are saying 126 and y, these are opposite angles of a cyclic quadrilateral. Cyclic quadrilateral is simply saying all the vertices are on the circumference of a circle. So meaning say we could have calculated y by simply subtracting 126 from 180. So it's going to be 180 minus 126 because we are saying these two are opposite angles of a cyclic quad. So still we're supposed to obtain the same answer of 54 degrees in that manner. So as we can see, any theorem, as long you are working with the correct theorem, you are supposed to obtain the same answer. It might differ the way that we calculated our values or the theorems that we are using, but as long we are using the correct theorem, we must obtain same answers. That is the advantage part of our of our circle geometry. All right. Then on the cyclic quadrilaterals, I think they tried to explain much further and so forth. But before that, let us just check number 3 here, because it is some properties that we have of parallel lines there, which needs to be put into consideration. We've got our question 3 here, that we are given a circle, and we've got letters to be found, which is letter F, G, and H. Okay, which part, what can we do? Which angle are you seeing that we can calculate easily, or that we can state easily? Some of the angles we might not state them because of the theorems. This is our center O. So, okay, anyone? What about the
H.
H? All right, we can get H from which one?
From
56.
56.
From 56. Why? Who the reason is going to be
Uh,
The Z angle. Wait.
all right, we are talking about a Z angle. All right, this one here is not a Z angle, this one, no matter how it looks like a Z. No matter how it looks like a Z. Why? These lines are not the ones which are parallel. So that means we cannot apply the Z concept. The Z concept is supposed to be from what? The lines which are parallel, these two lines. So we can apply our Z concept to say the angle at G here and this angle that we are creating at this point here. The angle at G, this one, and this one. These are the ones which are the same. That is where we are having a Z from the parallel lines. These two, we do not have anything for us now to say they are parallel, unless we prove, unless there's a theorem that can help us to prove. I'm not saying they are not parallel, but for now they are not, unless there is a theorem that we can use to prove that. If we calculate H later on, we calculate H, then we find that H is equal to 56. If H is equal to 56, what does it tell us? It tells us automatically that these two lines are parallel, because this cannot be 56 and this cannot at the same time. It's only if these two lines are parallel. So for now, we are not having that concept. All right. Any other part?
isn't that H is opposite to 56?
Hello?
Isn't that H is opposite to 56?
H is opposite to 56.
Yes.
How opposite? How opposite? From which concept do you want to apply?
Papa Manj.
Because we must have a theorem. If we are saying they are opposite, then let us have a theorem which is going to help us to say, okay, if they are, what is the relationship therefore after? So these two, they are not related for now. Okay, let us check about F. What is happening with F? We can simply find F, this one. We do not have to calculate it. What is the theorem? What does the theorem states about the diameter? A diameter subtends an angle
F
of
is
an angle of 90
90
degrees.
degrees.
So meaning to say
Yeah.
here, we have got what? We have got 90 degrees at what? At F. Are we seeing this concept? Also, this angle here is 90 degrees again, because we are still having the same diameter here. This is our diameter. It's creating again an angle at this point. We need to say we also have what? 90 degrees at this point here, isn't it? It's the same thing. What about G? From this 90 degrees that we just determined, can we calculate G?
Yes.
From where?
180
Exactly.
minus 90
So
is 56.
180 minus what? 90 plus what? 56, because we are saying these are angles in a what? Angles in a triangle. Are we seeing the concept? So here we are talking about angles in a triangle. Angles in a triangle. All right. So that means we can determine our G from there. So what is going to be our angle G? 90 minus 56 is what? Is 34. We can simply say 90 minus 56. Why? Because we know that these two angles must give us what? 90. Out of 180, we have removed this 90 here. So the remaining angles, 180 minus 90 gives us what? 90. So we can simply say G, it's 90 minus this one, which is one and the same thing with what you said here. So that's our angle G, 34 degrees. All right. From G, where are we going? To this angle.
H.
So we are saying this angle is going to be also 34 degrees because these two, they are parallel lines. So we are creating what? A Z angle. So from there, to find H, what are we going to do from 180? So 180 degrees minus our two angles, which is 90 plus what? 90 plus 34 degrees like this. We are going to obtain 56 degrees. All right. So at the end, we are back to that answer that you gave us in the first place where you said H is equal to 56. Now we can conclude to say it means also these two lines are parallel. If these two angles, they are giving us the same answer, it means automatically this line here is also parallel to this line. Why? These two angles, they cannot be equal, these two angles, if these two lines are not parallel. So that can be our conclusion at the end. But in the first place, that cannot work because you are not given that these two lines are parallel. You are only given this part here. So this is the one that you are supposed to work with to create other angles. So it can be by coincidence like this, whereby we are finding same answers. It's not like we are supposed to have this always. It's going to happen like this. It's just like a coincidence that happened. But it tells us at the end, as a conclusion, we can conclude to say that these two lines also, they are parallel. That is this line here and this line here. All right, so this is how we answer your questions. Even in exam, they might ask you a certain question. You're asked for a certain question that you are supposed to answer. But if you are seeing other questions that or other values that you can actually fill in on your diagram, try to do that. Fill in the values that you see. Okay, this one I know, this one I know. Fill in those values. From there, you see that, okay, this question that you are being asked, you have actually maybe filled in the, on your diagram. So it's another strategy of answering, to fill in what you can see, see exactly with your theorems. So this part, like I said, I want to concentrate on the cyclic quad. There's one part that I want us to check on the cyclic quad. Where did they give us these questions? I want us to just verify one part here, just to verify. All right, I think we can see this concept here. All right, on this one. We have got question C here. We are asked here to calculate the marked angle. So they just marked an angle, then we need to calculate that marked angle. So I want us to concentrate on C here. We've got a cyclic quadrilateral. If we check here, from this point to this point to this point to this point, we've got four vertices of a quadrilateral on the circumference of a circle, which makes it what? A cyclic quadrilateral. So we said from our cyclic quadrilaterals, what are the theorems that we have on a cyclic quadrilateral?
That corner there is 90 degrees. Next to C.
Next to C, this one.
Yes.
Why? All right. Let me say it this way. Geometry, it's from something that has got a theorem, something that has been proved to say it actually exists. Never assume in geometry, never assume they can have a condition where you can see that this is actually a diameter. By looking on your diagram, you can say this is actually a diameter. Never assume it's a diameter unless they have given us a center, or like this one, we've got center, or now we can say this is a diameter because it's from one point of the circle passing through the center. That is the major key that we can tell that, okay, this is a diameter. But without that, if a line is just drawn, never assume that it's a diameter. Like this one, never assume that it's a diameter. We have to be told that it's a diameter, or there must be a theorem that we can say, okay, once there's a center like this, definitely we are having a diameter. So it is the same thing here. Because of how these lines are drawn, that is not how we answer this question. We are not assuming that, okay, these lines definitely, it's a right angle that we can see. No, we'll miss this part. There must be a theorem. Which theorem are we using to say this angle here is 90 degrees? Which theorem is that one? If we can have a theorem, then it's fine. So this part we do not have a theorem, but this angle here, how are you supposed to find this angle, the same angle that you are saying? We say this is a cyclic quadrilateral. What are the theorems that we have on a cyclic quadrilateral? We said opposite angles of a cyclic quad should add up to 180 degrees. If you are given a cyclic quad, if you add opposite angles like this one, they must give you 180 degrees. If you add these opposite angles here, they must give you 180 degrees. And also the exterior angle of a cyclic quad is equal to what? To the opposite interior. These are the two theorems that we must keep in mind so far. Where as long we've got a cyclic quad, the exterior angle is equal to the opposite interior angle, which is this one is the opposite one. So this angle and this angle are the same. That these are the only two theorems that we are having on a cyclic quad. So can we try to use these two theorems for now? So what does it mean? What does
It
mean?
means 62. 62 is equals to the angle at the top there.
At this one. Okay, let me just name my diagram A, B, C, D, E. All right. 62.
Yeah. So 62 will be equals to E.
Will be equal to E. Which E? There are two E's there. There's this E here. There's this E here. The one inside or outside?
Outside the, yes.
This one here. All
And
right.
also 85 is equal to angle A.
Angle A.
Mm-hmm.
All right. So we are saying angle C here.
Mm-hmm.
This one, the 85, this one, or this one.
Yes.
The
No,
80
85.
and this one.
Yes.
There. You said they are. What is the relationship? What is the relationship between these two?
The opposite. I mean,
Yes.
straight
The
line. Yeah,
straight line.
opposite.
Yes, they are opposite. What is the relationship? If they are opposite like
The
this,
inner,
they must add up to 180. Opposite angles of a cyclic quad must add up to 180. Opposite angle. It's not because they are on a straight line. No. It's not like that. Are we seeing the concept there? So meaning to say here, we can calculate this E here, which is 62. The exterior angle is equal to the opposite interior. This is our interior. So this will be 62 degrees. Are we together? Sorry. So that will be 62 degrees, this one. All right. Then as we want to calculate this angle D, this one. So what can we do?
you said if we calculate, if you they are add up to 180. So if we add 62 and 62, they must give us 180.
Which one? No, not like that. This one, we are saying these ones opposite, like they must be inside the shape. This one, this angle here, this one. Are you seeing this angle that I'm indicating here?
Yes.
And this one. These are the opposite angles that we are talking about. But when we talk about this is now exterior. It's outside this one. It's outside of the shape. It's equal to this one. These two, they are equal.
So
So
did
that
you agree that angle A is equal to angle C?
it's not the same, this
Like,
one. This one and this one are not the same. But if you mean this one here, exactly this one here are outside of the shape, this one and this one, these are the two which are equal. Angle A here is supposed to be taken from 180 because these are the opposite angles, and we are saying opposite angles of a cyclic quad add up to 180. So meaning to say this angle at A there is supposed to be taken from 180 minus 85, which is going to give us 95 degrees. So this angle here, it's 95.
okay.
Are we seeing the concept there? And this angle 95 here is equal to this one here, which is the exterior angle now, the exterior outside of the shape. This one, are you seeing it? It is the one that is equal to this one. This is the concept here. The exterior angle is equal to the opposite interior. This one must be outside of the shape, equal to the opposite. This is the interior, but opposite in the opposite one. So this is what we have here. This angle, this is the opposite angle. Are you seeing that this is the opposite angle, this one? This one, the 85. But we are saying the exterior now, not direct the one that is, but the exterior, the one that is outside. Exterior simply outside of the shape. So the outer angle equal to the opposite interior. This is the interior, but opposite now. Exterior angle is equal to the opposite. This is the interior, but opposite this one. Must be opposite interior. This is the exterior angle, this is the interior, but the opposite one is the one that we are saying is equal to this. But these two, they must add up to 180, meaning to say this angle at E inside the shape, this one is simply going to be 180 minus what? 180 minus 62, this one. To find this angle, we could have said 180 minus 62, but it's not necessary for us to find this angle. All right, what can we do now to find the angle at D? If you check, we are now focusing on this triangle alone, this one, isn't it? So meaning to say, we can subtract from 180 because we've got two angles, this angle and this angle. So the angle that is indicated here, we just say D is going to be 180 degrees. So this one is going to be 180 degrees minus these two angles, 62 plus what? Plus 95 degrees, like this. So that is how we can obtain our angles in this case. So 180 minus these two, what are we going to obtain? 62 plus 95, that will be something like what? 23 degrees here, something like that. So this angle is going to be 23 degrees. All right. Instead of even focusing on calculating these two angles here, maybe you might had a confusion of determining these two angles here. What was the other option of still finding this angle at this one? What was the other option of still finding this angle? We subtracted this one from 180 and we got angle here at A. We can use the bigger triangle as it is, this one, from A to B to D, this bigger triangle. Still we can find our angle D. We are still having a triangle, and we know that angles in a triangle must add up to 180. So the angle D is going to be 180 minus these two angles, 95 plus what? Plus 62. So still we are going to obtain the same answer from there. I don't know if we are together. If we are together on this part. So that's how these questions might be given as. theorems, you need to master each theorem. Know each theorem by heart, each and every theorem. Try by all means, find time by yourself to memorize these, work on them. Just try to write them down. Draw a circle. If you are revising, just try to draw a circle. An angle subtended or angle created by a diameter is 90 degrees. You draw the diagram, you write the theorem just by yourself. Just try to write them and see how many theorems do you actually know by hand. List them down without opening a book and see how many theorems actually do you understand. It can help you to say, okay, this theorem I do not know, this theorem I do. So you work back now to those work back on those theorems that you be given. All right, then there's this confusing question that we are having here on question D. Most of us, we find it very, very confusing, but let's see what we have here. We are asked again to calculate the value of the unknown. I'm just going to write the letters here. Let's just say this is A, B, C. So we need to calculate this angle at C, which is BC or OCB, whatever way that you can say, OCB or BCO. How can we calculate this angle here? What can we do? Which are the stages that we can take into consideration?
I
All
think
right.
25 is 25 because you said the radius, something like the radius, or yeah, something like, I don't quite remember.
A radius.
Yeah.
It's true that OC and the OA, these are the radius that you are given, and the radius are the same. It's true that these two are the same, but these angles now, are they in a triangle that is created by these sides OC and OA? They are not. What we refer is this part here. If you are to join from O to C like this, if you join from O to C, then these two angles here inside the triangle, inside this triangle, O to A to O to C like this, these angles which are inside, this angle here that I'm indicating this one, and this angle here that I'm indicating this one, these are the ones which are equal, not these two here. These two, they cannot be related, these two. Are you seeing they are not inside a triangle? We do not know this shape. Are you seeing the shape that is created there? It's not even a triangle, that one. It has got how many sides? 1, 2, 3, 4 sides. So it's not a triangle. So are we seeing the idea there?
Yeah, but I'm
So,
also thinking that if we can find that those angles in the small triangle, we can also find that angle that we are looking for.
all right, we try to determine these two angles here.
Yes.
All right, no problem. Let's see. It might give us what we want. Like we said here, we are going to join. All right, no problem. Let's see if it is going to end up at the point that we want. So to find this angle, like we say, these two will be equal. So this angle and this angle, we can simply subtract 116 from what? From 180 divided by 2. So 180 minus 116 divided by 2 is going to give us something like 32. So this is going to be 32 degrees. This is going to be 32 degrees. All right, from there, what can we do now? If we have got these angles, how can we reach to that this angle to this remaining angle here? Because as we are focusing on finding this angle, so it's going to be difficult for us to determine. Yes, you are saying?
I thought I can multiply it by 2. Since I've got a big triangle now, then I would remove that small triangle inside.
This one. Then we are saying to find this one, what's going to happen?
I would multiply 32 by 2.
All right, from which theorem? if we have a theorem. So everything, you see what I was saying, must be from a theorem. Never assume in geometry. The moment you see something like this, you assume we are going to have a challenge. Even if you check, do you see what is happening between? Are these two angles related? This one, 25 here and 32. Do you see that?
No.
It is the same thing that we are seeing here. This angle here and this angle here. So it means these two, they do not have any relationship. They do not have. All right, so this is how we're supposed to answer this question. I want you to check something here. From this point here, this is a quadrilateral. From A to O to B, back to this point, this is our C. Let us just say this is our C here, to B here, back to A like this. This shape has got four sides. This is a side, this is a side, this is a side, this is a side. So this shape have got four sides in this case that we are seeing. So it means it's a quadrilateral. We can calculate this angle at B. This one, we can calculate this angle because we know that this is the angle at the center. If we join here, you can see the chord AC is creating angle of 160 at the center. The same chord AC is creating an angle here B at the circumference. So meaning say B is going to be 116 divided by 2 angle at the circumference. So 116 divided by 2 is going to give us something like 58 degrees, meaning to say we have got this angle at B here. Okay, like I said, this is a quadrilateral, meaning to say angles in a quadrilateral must give us 360 degrees. We can calculate also this O here, the bigger one, this one, inside this shape, this one. We can calculate this angle from where? Angles at a point, we say they add up to 360. So meaning to say this angle O, we are going to subtract 360 minus 116. This one. If we subtract 116 from 360, we are going to have something like 244 degrees, which is this angle here that is out here. But we are saying angles in a quadrilateral, no matter how you see the shape, how it looks like, as long it has got four sides, it means the angles must give us what? Must give us 360 degrees there. All right, so if we are to check, I was saying, as long you are given a shape with four sides, no matter how it is being presented, a quadrilateral is simply having four sides. No matter it's given this way that we are used to or this way, we are still having the four sides concept. So meaning to say angles inside must give us what? 360 degrees. So now we can be able to calculate this angle here. So maybe this angle we refer to it as x because we do not know, it's just an unknown value, this one. So we can simply say our x now is going to be 360 degrees minus all these other angles. We've got three angles inside, which is going to be 25 plus 58 degrees plus 244 degrees. So that is going to give us the remaining angle that is inside. So I don't know what we are obtaining there. 825 plus 58 plus 244 from 360, that will be something like 33 degrees. So this is the angle that we are having here, 33 degrees. So are we seeing that these two, this one and this one, they do not have a relationship? We cannot apply that concept. We are supposed to work with the exact concept that we are having here, which is to try by all means play around with your diagram, find other angles that you can be able to find up to the one that you are given. All right, I don't know if we are together. If we are together, I don't know if we are still together.
Yes.
If
Yes.
we are still together. All right. I can't hear. Don't be. I can't hear. Can are we together? Because I'm
Yes.
not. hearing any response, or it's maybe on my side, or I don't know. All right, so I wanted us to check this other question here. There is from those ones that we started with. There's a theorem that we just want to let's just add on our tangents. I want us to get back to our tangents. So I want you to add more questions from these ones, from this other booklet. This one, I think I sent it, the one with the notes. I want us to check on the tangents there. Remember we talked about the issue of a tangent here on this part. Where was this part here? On this one, we talked about the issue of a tangent meeting a radius and two tangents from the external point of a circle, that they are equal when they meet. There's also this theorem on a tangent again, which states that if you are to take here, there is a tangent that we are seeing at 80 from A to T. We've got a tangent here 80. So the angle that is found between a tangent and a chord, this one, we've got an angle between a tangent and a chord. It's found in between. So this angle that we see here is equal to the angle in the opposite segment, which is this one, the angle in the opposite segment. So we are simply saying an angle between a tangent and a chord. So you hold the chord. You see it's between this tangent and this chord. So you hold the chord, this one, the chord AB. Where is it creating the angle? It's creating the angle at C. The angle at C is the one equal to this angle between the tangent and what? And the chord. If I was to extend from this side, I want you to see if we had to work with this tangent here like this. Meaning to say there's an angle between here, a tangent and a chord. If we are to check here, there's an angle between a tangent and a chord. This angle here will be equal to this angle. These two, they will be equal. So that is our theorem. So we are simply saying angle between a tangent and a chord is equal to the angle in the alternate segment, or in the so this is what we are given here. The angle between a tangent and a chord is equal to the angle in the alternate segment. So this is our theorem up to this point. So this is known as the alternate segment theorem, to say these two angles are the same, the way that we can see x here, this one is x. So meaning to say if this is 50 degrees, this is going to be 50 degrees. That is what we simply need to know. So as we can see, this topic is already done. It's all on the theorems. The more theorems that you work with and the more questions that you can work with, the more that you can understand these typical questions. So I just want us to check one question which involves about this part of a tangent, so that we just clarify between these tangents. If you check on this exercise, here there are so many questions that we are given here. Work out the size of each of the marked angles that we are given here. So I want us to see this one here, where it is actually given on C part here. If we are to check on this diagram here, we have got a tangent. This one is a line that is just touching the circumference of a circle. So this angle between, which is the angle D, this one, is the angle that is between the tangent and the chord. Tangent and the chord. But where is it creating the angle? This chord AB. If you check, AB is creating the angle at the center, not at the circumference. AB is supposed to create an angle like this. This is where our theorem is working. Angle between a tangent and a chord. You hold the chord, which is our chord AB, this one. Where is it creating the angle? It's creating the angle here at the circumference. So this angle here and this angle are the ones that we are saying they are equal. Not this one for 27, this one, no. 27 is not the one that is being created. The chord AB is the one that is creating the angle. It's creating at the circumference. So meaning to say, we can be able to calculate this angle, C, then we find this angle by dividing by 2. We know this. By finding this angle, we are finding this angle. But how can we calculate angle C? we are back again to our radius concept. Or B is a radius, or C is a radius. So meaning to say this angle at B is supposed to give us what? 27 based also in isosceles triangle. So this is going to be 27 degrees. To find angle C, we are now saying angles in a triangle. So C is going to be, we add these two angles from 180. So that's 180 minus 27 plus 27 degrees. So meaning to say we have got our angle C. So that's 180 minus something like what, 54, which is going to be 126 degrees. So by finding C that is 126 degrees, it means we can be able to determine angle D, because this C can be related to this angle that we are indicating here, because it's a half, it's at the circumference. So this one, 63, if we divide this one by 2, that will be 63 degrees. So if this angle is 63 degrees, that means also this one is also 63 degrees there, because we are saying these two, they are related from what? From the concept of angle between a tangent and what? And a chord. So that is how we can answer these questions. So I want you to work as much questions as possible, so that we can be able to say, I wanted us to extend as much time, but let us just try to work up to this part. We'll see the other part tomorrow. Let's just work from what we have done, the theorems that we have done. Let us just try to work on more questions. We still have a lot that we can actually relate to, or that we can work from. But for now, let us just work from our basics, these basics that we are having from that PDF that I sent. We together. Right.
Yes.
Seems like
So I have a
somehow
question.
this meeting has disturbed our mics. I don't know, because I can't hear your responses. Okay. Anyways, let's see. Tomorrow we add up. So maybe let's just see what we can work on from these exercises here. I want you to just work from this part here. Just try to work on these questions. There are so many questions, even the hints you are given on how to do this one, but it's not like you're going to be given like this in exam. So let us just work these ones from this booklet that I sent, from those notes. These ones, let us work as much as we can from these questions. Sometimes you need to make adjustments on your diagram. If you see there is a need for you to make adjustments, like what I was doing on this question, sometimes there's a need for you to make constructions on your diagram, like on this part here. We can even make further constructions for you in order for you to answer the questions that you want to answer. But every construction must be from something that is relevant from our theorems. We are supposed to work with our theorems. So yeah, we'll see tomorrow. We'll see tomorrow. You said you have a question. Is the question on WhatsApp, or is the question on WhatsApp? Or all right. The questions. Can we send the questions on WhatsApp, because I can't seem to have your feedbacks. I don't know, it's because of this meeting or what. So if there are questions, let me have them on WhatsApp. Let me, that can actually help. Then the rest we'll see it tomorrow.